Let's use partial fractions to integrate 4 plus x divided by negative 2x squared plus 5x plus 3 dx. Before we get started, we have to make sure our denominator has higher degree than our numerator. And in this case it does, because we have a second degree polynomial in our denominator and a first degree in our numerator. So that means we can use partial fractions, and the first step to partial fractions is factoring our denominator. And that will give us the integral of 4 plus x divided by, factoring this denominator, 2x plus 1 times 3 minus x. So we can see here that we have case 1, which means that our denominator has distinct linear factors, because 2x plus 1 and 3 minus x are both linear, and they both have multiplicity 1. That means we can rewrite our integral as some constant a divided by our first factor, 2x plus 1, plus some constant b divided by our second factor, 3 minus x. Our next step is to use this information to create an equation to solve for a and b. So if these two integrals are equal, that must mean that these integrands are also equal, giving us 4 plus x divided by 2x plus 1 times 3 minus x is equal to a divided by 2x plus 1 plus b divided by 3 minus x. And we should always simplify, so we multiply both sides by this denominator. On this side, we'll just be left with 4 plus x. If we multiply this fraction by this denominator, 2x plus 1 will cancel, giving us a times 3 minus x. And if we multiply this fraction by this denominator, 3 minus x will cancel, giving us b times 2x plus 1. To solve for a and b, we choose values for x that allow us to cancel one of our constants so that we can solve for the other. So for example, if we choose x equals 3, then this becomes 3 minus 3, which equals 0, canceling out a, and then leaving us with only b to solve for. So let's try that. If x equals 3, the left side becomes 4 plus 3. The right side becomes 0 plus b times 2 times 3 plus 1. And now we're just left with b. Solving for b, we get b equals 1. And now we can substitute this back into our equation, giving us 4 plus x equals a times 3 minus x plus 1 times 2x plus 1. Now we just have a to solve for. And we could choose any value for x that we want, as long as it doesn't cancel a out. The easiest thing we could do is choose x equals 0. So let's choose x equals 0. And if that's the case, the left side becomes 4. The right side becomes 3a plus 0 plus 1. And then solving for a, we get a equals 1. Substituting these values back into our integral gives us the integral of 1 divided by 2x plus 1 plus 1 divided by 3 minus x dx. And we can write that as a sum of integrals, giving us the integral of 1 divided by 2x plus 1 dx plus the integral of 1 divided by 3 minus x dx. So we can see why partial fractions made this easier. We took a complicated function and turned it into a sum of smaller functions that we could integrate more easily. For this integral, we'll use u substitution, where u equals 2x plus 1, and that will give us 1/2 ln absolute value of 2x plus 1. And for this integral, we'll use u substitution, where u equals 3 minus x, and that will give us negative ln absolute value of 3 minus x. And then we'll just add plus c for our constant of integration.